It's the 17th of March, 2015, and this is episode 196. This show is intended for informational and educational purposes only. What cryptocurrency enables is new, empowering, and exciting, but we're not experts, just obsessed companions walking the road towards a more peer-to-peer future.
Hello, welcome to Let's Talk Bitcoin. I'm Matthew Zipkin, and today on the show we're joined by Evan Duffield, who's the founder and lead developer of DarkCoin. How's it going, Evan?
It's going great. Good to be here.
DarkCoin started about a year ago?
Yeah, it's been about 14 months now.
Why did you decide to take cryptocurrency in this direction?
DarkCoin started as a project that was intended to be a privacy-centric currency. And as such, we wanted to improve the fungibility and privacy of its users. This was done so that when you receive coins from somebody, the transaction history doesn't actually come with the coins, because it's kind of risky, depending on where the coins have actually been, that you might be holding some coins that you might not actually want to be holding. So this type of technology actually makes all of the coins equally fungible. So it was really important to me to make a currency that actually fixed one of these core issues with Bitcoin.
This sounds like the primary feature of DarkCoin is that you combine transactions in a certain way so that the direct blockchain trail is sort of obfuscated. Is that right?
The way it works is we utilize a decentralized mixer that lives on the network itself, and users can trustlessly join in transactions with other users. And they denominate their coins just like you would with cash. So it's kind of like a few people sitting around a table, and they get out their wallets and they take their $20 bills, their $10 bills, and their $5 bills. And you put them all in the middle of the table, and then you mix them all up, and everybody takes the amount of money they're owed back. But no one knows who has what money anymore.
Okay, because that's the main problem with the shared send procedure in Bitcoin, is that you can tell which input belongs to which output because of the amount is the same going in as it is going out. So you've kind of made a standard set of denominations for these coins so that all the inputs and the outputs are even more likely to be mixed up.
Yeah, exactly.
And are those numbers constants, or are they somehow adapted as time goes on?
They're constant. They're in the code. So for a given version of the software, we have a few values that are used. Currently, it's 0.1 DarkCoin, 1 DarkCoin, 10 DarkCoin, and 100 DarkCoin. When you use DarkSend, it actually breaks up the amounts into those denominations, and then you request someone else on the network that has the same denominations. And then you use what's called a master node to host the transaction that makes the coins anonymous.
Okay, that's cool. I definitely want to talk about what the master node's doing, but just to sort of set a basis for how this works is you need to find other people around the same time who are also interested in sending a DarkCoin transaction, and their inputs and your inputs and maybe inputs of a third person, they all get combined together to produce an equally complicated output, right? So that the one-to-one transaction history isn't there.
Yeah, and this is an ahead of time mixer. So you open up your wallet, and let's say you have a couple hundred coins or something that you would like to anonymize. So you click the Start Mixing button, and then your client will continually ask for other clients on the network without revealing any kind of compromising information. And then as time goes on, you'll continue to mix until the coins have a substantial amount of privacy, at which point they can be spent at any time into the future. So timing attacks don't actually work on this because you're not trying to send money when you're doing the mixing. The two are completely separate.
I see. So the wallet is essentially making transactions all the time using this mixing process. So when you actually want to, say, buy something, it's just another transaction that's just like any other of these kind of random looking transactions. Is that it? You're sort of like increasing the noise so that the signal is harder to find?
Yeah, so imagine a transaction with only ones, tens, and hundreds. And then you had 3 people in that transaction, and there's like 40 inputs and 40 outputs. Your coins go through, 2 or 3 of these. And then at the end, when you actually want to send coins, use the last outputs as your inputs for the next transaction. And then you actually make the transaction. So you can't follow the history back through the process.
Oh, okay. So the mixing is a sort of an initial process, and then once your coins are mixed, then you can just do a one-to-one transaction or something. You don't need to use a mixing transaction if you're just trying to send somebody money.
Oh, yeah, that's exactly correct.
When all this mixing is going on, are there miner fees on these transactions that are being paid as a part of this constant sort of ongoing mixing process?
There are special transactions that only the master nodes are allowed to make. And these transactions are actually subsidized on the network. So if you tried to run DarkSend on, say, Bitcoin, it would be insanely expensive. Instead, we really want the fungibility built into the currency. So we're subsidizing this and allowing those transactions to actually not have fees at all.
They have no fees because the DarkSend is being subsidized to the masternodes by the miners. But does that create an incentive for people to use DarkSend for every transaction, thus leaving the miners with less transaction fees?
Well, the DarkSend process is ahead of time. So once you mix coins, they're mixed. And then you can actually just send transactions normally after that. So there's no incentive to just keeping mixing your coins over and over again. I mean, once they're mixed, they're already private and anonymous.
Right, but since you know that's going to be a free transaction, can't you use that to make a purchase or something like as your actual transaction and avoid paying a fee?
The system actually doesn't allow you to do that. You can only pay yourself, which is why you can't lose money doing it.
Can you enforce that on the protocol level that you only pay yourself?
No, if somebody wanted to alter it to pay someone else, they could. And let's say they did that and then they started using DarkSend for everything. The collateral transactions are charged every once in a while to avoid that type of situation. So 1 in every 10 of these mixing sessions, you pay a few cents. So you would end up running up a pretty big bill just mixing over and over and over again.
Okay, I see. So the house does rake the pot, so to speak. It's not totally absolutely free all the time to do the mixing.
Yeah, it's just really cheap.
Okay, got it.
So you can mix your coins for free. And once in a while, you'll get charged what's called a collateral fee. It's another nifty thing because with CoinJoin, any person can stop the join by just not signing the end transaction. So once you start a DarkSend transaction, you actually give collateral to the masternode. And then that collateral is held. And if you don't do anything you're supposed to do, then it'll actually be cashed in. So you have to follow through. So if somebody hacks the client to try to break DarkSend, they'll end up paying collateral every single time. And besides that, it's a protection, and once in a while, the masternodes will actually charge the users fees for the transactions that they're doing. And those are actually apart from the joined transactions to improve the anonymity.
So you do eventually get the collateral back if you behave.
Yeah, exactly. You don't lose it unless you do something wrong. The client is programmed in such a way where once you start the DarkSend mixing process, if the masternode wants you to mix, then you'll go through with it and make the transaction. There's really no issue unless either the masternode itself is trying to steal from you, which you would know because it's trustless, or your client is trying to manipulate the masternode somehow. And in that case, you would get charged.
Okay, this is confusing me a little bit.
Okay, so when you enter these pools and you enter with 2 other people, all 3 people have to sign. So what happens if one client refuses to sign? Well, nothing happens. It just fails and it just needs to start back over again. Somebody that wants to attack the system can literally bring it to a halt.
I see, by creating transactions and never signing them.
Yeah, the solution to this was you put up collateral, you give it to the masternode. It's kind of like a check, and it's a check written out to the miners. And if you do something wrong, like if you're trying to attack the system, then they cash it.
So how is that transaction generated? Is it like with a lock time? How does it work like a check? How do you eventually get the coins back?
We're talking about implementing it with a lock time, but currently it's not. But even if a masternode wanted to cash your collateral, it would end up going and paying a miner. So they really don't have an incentive to do it. Plus, you're using more than one masternode, and you're using them randomly across the whole network. So the chances that you actually hit one that is doing that is nearly zero.
Okay, let's just talk specifically about the architecture of these masternodes. What do they do that's different from a regular node, and what do they do that's different from a miner?
So masternodes are full nodes. And the idea here is in Bitcoin, they have currently about 6,000 full nodes. And there's really no incentive to run a full node. A full node actually costs money to run because you have to either pay for a VPS or you have to have hardware you're running it on. Then there's bandwidth costs. So to fix this issue, we implemented an incentive system where the full nodes that are ran as master nodes actually share part of the block reward. So you put up collateral to become a masternode, which is 1,000 DarkCoin. And then you share in the block reward, which currently is about $32 a month in revenue that you get, which covers your server costs and actually gives you a little bit of profit.
So when the miners mine a block, part of the block reward goes to these masternodes. And how are the masternodes prove that they deserve part of the subsidy?
So that's called proof of service. And what they do is they ping the network every few minutes. And they ping it in such a way where only they can do it because they're signing with a key that only they have. And then the rest of the network acknowledges that they're still there. They also have a port open. So a full node on the Bitcoin network and the DarkCoin network has a port open so that anybody can come use it and, use the services like syncing from it or broadcasting a transaction or things like that. So they have to prove that they're doing both of those things.
So they sign the time of day with their key and just broadcast that as a message on the network?
Every block that happens, there's 1% of the masternodes that check another 1% of the masternodes. Make sure their port's open. They'll send them messages and make sure that they're actually responding correctly and make sure they're actually responding to like instant X and things like that. And you could also enhance it to make sure they have like a specific CPU speed or bandwidth requirements, all those types of things.
And that proof of service model is how the masternodes earn the percentage of the block reward from the miners?
Yeah, when a masternode receives a new block, it'll check to see if it's responsible for checking another masternode to make sure that that one is participating in a way that it should. And if it's not, it gets penalized. And if it gets enough of those penalty messages that are broadcast through the network, then it actually gets removed from the payment list.
Okay. And what happens if a miner decides to be greedy and not pay out to the masternodes? Are those blocks rejected by the network?
Yes.
Okay, so everybody is watching all the masternodes and making sure that the masternodes are getting their fair share.
Exactly. Yeah, that's how it works. And then there's actually a list kept all across the network of all of the current masternodes. So everybody on the network knows about every masternode. And so like when you use DarkSend process will actually pick random masternodes from that list and use them for their services.
I see. So it's a little bit like Tor where there's a directory.
Yeah, kind of like that.
These masternodes are the ones that actually combine transactions. These are the things that are replacing the centralized coin join, or in Dark Wallet, there are servers that make the shared send possible. So you've managed to distribute this by putting that job across the network onto these specialized nodes that can prove what they're doing and earn part of the block subsidy with that proof.
Exactly.
Got it. What is the privacy factor with the masternodes? How do you trust them not to log the inputs and the outputs?
It's a little bit like the way Coin Shuffle works, if you know how that works. The way that you know that the masternodes don't know which coins you're actually getting from the transaction is the coins that you send to it, the inputs and outputs, you actually relay through other masternodes. So you'll pick masternodes randomly on the network, and then you'll relay through those to the target masternode that's actually hosting you. And then it then sends a request saying, hey, these are the inputs that I know about, and these are the outputs that I know about. And then all of the participants, again, start sending all of those out and relaying them again through this target masternode with new ones. So no one can really tell whose inputs and whose outputs belong to who.
So you don't send your inputs and outputs to one single masternode. What you do is you send a message to one masternode that announces to the network that it is creating a mixing transaction. And once that announcement has been made, inputs and outputs get sent to that masternode from all over the network, including your own, but the masternode doesn't know which inputs and which outputs you specifically are sending to it.
Yeah, it actually happens in trickles. So every few seconds, you send a few of the inputs and outputs. And then this happens with all of the participants. So then every few seconds, the masternode says, hey, this is the transaction I have so far. So then you see all of the inputs and outputs in the transaction from the other users too. And then you relay the trickle of those through the network again. So you're relaying the other users' inputs and outputs through the masternodes.
So my client is keeping track of other inputs and outputs that are coming to other users, and I mix in my inputs and outputs with those inputs and outputs, send them to the masternode, and the masternode doesn't know where anything came from.
Yeah, it has no idea.
Right. And then, of course, if the masternode drops an output that you needed, you just won't sign the transaction.
Yeah, you check to make sure that all of your inputs and all of your outputs are exactly as you intended them to be. Otherwise, you just don't sign.
Got it. In Bitcoin, there's the SIG hash flags where you can say I'm only going to sign one input or all the inputs and one of the outputs and all those funny kinds of things. Are the dark send transactions, are they SIG hash all?
Yes.
Okay, so everybody agrees on the entire transaction.
Yeah, and then if, let's say, you refuse to sign or you're missing an input or an output because the relay failed or something, then it falls back to what's called downgrade mode, where you actually just send the direct communication to that masternode. So that if somebody is trying to break the system, they can't actually trick the masternode into just letting the transaction fail. So most of the time it works. We call this masternode blinding. So you relay through this node, you make the final transaction. Nobody knows whose inputs and outputs belong to who. And then you can actually send the outputs of that transaction through a different masternode and do it again. And so it tracks if it was downgraded or not. And then you can count like how many times you actually were successfully blinded in this transaction or how many times that it was downgraded.
So the wallet itself has like a privacy threshold, and if it's not reached on 1 or 2 rounds, it just keeps going until it's satisfied that the blinding has occurred, that 2 different nodes got the inputs and the outputs.
Yeah, exactly.
Well, that's pretty cool. That's a good idea.
Yeah, it's a little complicated, but it works really well in practice.
Okay, and then there's also regular nodes and regular miners that work just like the Bitcoin nodes and miners, where there's somebody hashing blocks and doing proof of work, and the rest of the nodes are just passing these transactions around.
Yeah, we call this a 2-tier network. So you have one tier that provides all of these extra services, which is a specialized masternode network. And it provides the DarkSend services. It also provides all of the full node services. And then you have your normal network, which does everything that you were just mentioning, all of the same type of stuff.
Okay, well, let's talk about some of the other features. So your mining algorithm is it script or SHA-256?
At the very beginning, I implemented X11. So X11 is a series of 11 algorithms that are chained together. And as a result, the miners run a lot cooler. So GPU miners have experienced about a 40% decline in electrical usage mining DarkCoin. And the X11 algorithm has become incredibly popular over the last year. There are a ton of coins using it.
Can you explain a little bit about it? There's 11 different hashing algorithms in a series.
Yeah, so it was all of the SHA-3 candidates. And then I put those together. So it hashes through one of the candidates, then it hashes through another, then another, then another. And the chain actually causes the hardware to have to reset or take a break, which then slows down the process a little bit, making the hardware actually run a lot cooler, which decreases the electrical consumption of the network.
Sure, that's cool. Does it also provide some kind of ASIC resistance because the algorithm is so complicated?
Yeah, it's very difficult to make an ASIC for X11. We expect that they'll be made eventually, but at this point, there are none.
So are people mining DarkCoin on GPUs?
Just GPUs. It started as CPUs, and then a GPU miner was made in the first few months, and that's what we've been mining on since then. We're trying to follow the same cycle that the Bitcoin project followed, where it went from enthusiasts running it on CPUs to GPU miners and then to a more professional ASIC network. But we didn't want to just skip all of the development that the Bitcoin network went through, because it was actually really healthy for the Bitcoin network to go through those stages.
So your block time is also quite a bit shorter than Bitcoin's, is that right?
Yeah, the block time is 2.5 minutes, so it is a lot shorter.
And are you experiencing any higher orphan rate with that time?
I haven't noticed any higher orphans. We definitely don't have any issues with that. Generally, people wait for 6 confirmations, but with the addition of the Instant X technology, we actually support instant confirmation.
Great, let's talk about that. How's that work?
This was another interesting invention that came out of the masternode network. We actually were able to provide confirmation for transactions in about 4 seconds by utilizing the masternode network to verify transactions. Basically, what they do is they sign the transactions that they see, and then they say, yeah, I approve of this. And they form what's called a quorum. So you take 10 random masternodes out of the full masternode network, and then they sign the transactions, and then they propagate. And if the network sees 10 of these signatures from the quorum participants, then they will lock the transaction. We call a consensus lock. And it means that the transaction after that point is double spend proof. So if you tried to mine a block with a conflicting transaction spending the inputs of a locked transaction, it would just be outright rejected from the network. Or if you tried to get something in the mempool another way, it would also be outright rejected. So it makes it safe to take confirmations after that initial 4-second period. After the initial instant X confirmation, we call it masternode level confirmations, and it gives you 5 of them. And then the next confirmation comes from a block level confirmation, so that gives you a total of 6. So on average, to get 6 confirmations on the DarkCoin network takes about a minute and a half.
This episode is brought to you in part by another project I'm spending much of my time on, Tokenly. Tokenly is an open source project building server-based tools to make decentralized tokens actually useful to individuals and businesses. In doing so, we create new opportunities that haven't yet been thought of, because previously they weren't possible. If you'd like to learn more, have questions, or want to get involved, whether helping design and build tools or as an early supporter of the project, send an email to team@tokenly.co. Today's magic word is dash. That's DASH. Dash. You've got until the 24th of March to visit letstalkbitcoin.com or the Let's Talk Bitcoin iOS app to enter it for your share of the listener rewards. Back to the show.
So on average, to get 6 confirmations on the DarkCoin network takes about a minute and a half.
Oh, that's cool. And the masternode confirmations come so much quicker because there's no proof of work. They just sign it and send it right back.
Exactly.
How easy would it be to implement something like that in Bitcoin? I guess because the masternodes have this extra kind of citizenship.
If you allowed all of the nodes in the Bitcoin network to perform this type of operation, let's say you started tens of thousands of nodes on EC2, you would actually participate in this. And then you would try to trick the system, and you could actually do it. But with masternodes, it requires 1,000 DarkCoin per masternode. So there's no way to gain majority without spending enormous amounts of money.
It's a bond. The masternodes have to put up this bond, and that's how they gain the trust to be able to sign the masternode confirmations.
Exactly. And that's actually how DarkSend is secured too, because you can't start 1 million nodes and host these transactions.
Right, because it would just cost too much.
Yeah.
Again, let's talk about how the bonds work. They're not like a time lock transaction. So you have to prove to the network that you have these coins and you can't spend them while you're using them as collateral?
Yeah. So basically, let's say you're an investor in DarkCoin and you have a few thousand coins. You can either keep them in a cold wallet and let them just sit there, or you could support the network. And what you do is you send 1,000 DarkCoin in a single transaction to your cold wallet, and then there are API commands, and you set up a little configuration, and you sign that 1,000 DarkCoin address, and you propagate a message to the network, which then remotely starts a hot node. So the coins that are in the collateral actually are not on that hot node. And that hot node is actually running, doing all of these services. So now your coins are safe in your cold wallet, just like they would have been any other way, except now you have this hot node and it's performing those services.
It's cool because you've kind of integrated this element of proof of stake where an account balance, everybody knows your account balance and that gives you a type of priority. I wanted to make sure I understand this though. So I've got 1,000 DarkCoins in my hot wallet and I send that to a cold wallet. So there's a private key that stays offline. I never have to use it. But by doing that, I've proved to the network that the hot wallet at one time had the 1,000 coins, and then I can use the private key for the hot wallet to say sign these masternode confirmations.
Yeah, exactly. So there's a shared key between the two. You have a configuration and you say, here's my shared key for the masternode in both. And then what happens is you sign the 1,000 DarkCoin and then you say, here's the shared key also. So then it activates the other one, which receives that message being propagated across the network and says, oh, I've just been activated.
So it's not just like sending from a hot wallet to a cold wallet. It's a special kind of transaction that proves to the network that you've made this bond and you are now ready to masternode.
Yeah, these are all custom protocol extensions. So there's no multi-sig or anything like that. These are all like enhancements. It's like tens of thousands of lines of code that have been added to DarkCoin to do these.
Is there anything else that the masternodes can do besides the Instant X and the dark send sort of functions?
Well, yeah, there is another thing that's been happening recently on the Bitcoin network. There's an ongoing Sybil attack where 5% of all nodes are monitoring all of the users' transactions, and they're actually de-anonymizing the transactions and recording the IP addresses of where they came from, which, that's a pretty big invasion of privacy. Well, what you can do is to use the two-tier system. So when you relay a transaction, you just connect to a random masternode, and then you say, hey, can you relay this transaction for me? And then the masternode relays it, and to the network, it looks like the masternode is the one making that transaction and not you. So your privacy actually remains intact.
And how do you prevent that masternode from recording your IP address and knowing everything that you do?
Well, there's thousands of masternodes, so it would be one client on the network that knows who you are. And then beyond that, you could improve it so that you actually relay through multiple masternodes. So you say, hey, over here, can you relay this transaction to this other masternode? And then that masternode relays it in a very similar way to the way Tor works. And then the last masternode is like the last hop, and then it actually relays it. And the only IP address it actually knows is the prior masternode.
Got it. But there's no encryption between the nodes, so it's still potentially susceptible to a man-in-the-middle attack?
There's no encryption between those masternodes, but you could always add that too. But it still enhances the privacy of the user.
Are you planning on any other features for the masternode? Any other jobs?
Masternodes can do a great many things. Because it's a two-tier network and you have the collateral, so you can't actually take control of it without enormous amounts of money, we're able to do things like two-factor authentication at a protocol level, which means that you could sign an address and coins can freely go into it. But to come out of that address, you would have to use one of these two-factor applications on your phone and enter a code, which would be put into the transaction. And then for that transaction to be honored, it would have to be validated against your pre-existing two-factor.
That's cool. So you'd combine a wallet on your phone with a wallet on your desktop, let's say. So does that work like multi-sig? There's two private keys? Or is the masternode doing like a challenge response or something?
We're still investigating how to actually implement that, but we're looking into a solution like multi-sig and a challenge response solution. Haven't actually picked which one we're going to go with or even which two-factor authentication API we're going to use. But the masternode network is definitely capable of doing something like that.
That's cool. How many masternodes are up and running right now?
Currently, there's 2,300 of them.
Oh my God.
Yeah, so it's pretty amazing when you incentivize people to start full nodes and you actually pay them for the services that they're providing to the network. Because we have, I would say, less than 1% of the Bitcoin market cap, but we have almost half of its full nodes. And if we wanted more full nodes, you just decrease the amount of collateral required to run one of these. And then suddenly we just have more.
That's interesting. You're using the market more to keep the network alive.
Yeah, and even more than that, let's say we wanted full nodes with specific specifications, like you want master nodes to have 10 gigabytes of storage. Well, let's say we have 2,300 nodes, 10 gigabytes of storage. Now suddenly we have 23 terabytes of storage on the network. And you could treat that like a distributed hash table and store encrypted blobs. So we could run a web wallet where you actually connect decentralized to a masternode, any masternode, and you use its like Apache or something, and then it serves up the web wallet. Now you enter your username and password, it downloads, it figures out where your blob is stored, downloads that, decrypts your blob against your password and your username. Now you have the keys to your money, and then you could use the API on the masternode to broadcast transactions, set up multi-sig, see what's in your accounts, and do all sorts of things. Very, very powerful system.
That's really great. Is there a way to prove to the network how much storage you have? How would you accomplish that?
We're actually working on trying to figure that out right now. There's a couple possible ways that we're looking into, but we haven't settled on one yet.
Have you looked at the MadeSafe project? Talked to those guys at all?
I've not. I've looked into the MadeSafe project, and it's really interesting, but I have not seen what they're doing. That actually might be incredibly useful for this too.
But that's way down the road. Mainly what you've got is a privacy-based currency, and you've got some really fast transaction times, and you might in the future also have two-factor authentication at the protocol level.
Yeah, I was just trying to show there are lots of things that can be done with a two-tier architecture. I mean, it's pretty much unlimited.
Yeah, I can see how that would be a big advantage. Are the things like the collateral amount and the master node block percentage, are those things hard-coded? Do you need to adjust those with forks in the future?
Did want to change them, we would have to adjust them with forks.
Actually, I know you have something called sporking.
If we ever did change any of those amounts, we could actually do it with a spork. Sporking is an interesting feature. It's somewhere between a hard fork and a soft fork. And what it allows you to do is, in Bitcoin, they have to test things to death. And it's a slow and painful process. But with a spork, what you do is you test it and you try to prove that it works to the very best of your ability. And then you can push it out to the network. And if something goes wrong at some point, you can actually disable it. So then the code just goes right back to where it was before the hard fork. It basically turns off a section of code. It can also send variables. So we don't do this currently, but you could set the amount of collateral required for a masternode with a spork.
Okay, and who gets to decide when a spork happens and when it needs to be reversed if something goes wrong?
The way a spork works is there's a key that the developer has, and they're able to turn off and on these whenever they need. But there's only a few active at a time.
So that's interesting, because in Bitcoin, there's, I forget which bit it is, where the miners sort of vote on a new version number, and once it reaches 75%, it goes into effect, and once it reaches 95%, then old blocks become rejected by the network. What do you think of that model compared to what you've implemented in DarkCoin?
I think that's called the supermajority model. And it's a great model and it works really well for Bitcoin. It's not reversible. Let's say the Bitcoin developers messed something up and the network was broken by one of these forks. Well, they would have to actually commit something to reverse it and then have the whole network update. Whereas with a spork, you could even combine a spork with the supermajority code and let the network update slowly and then reject blocks eventually. But if something happened, you could just turn it off if you needed to.
I see. So the advantage of having a spork is that reversibility, that you can send a message to the network and go back.
Yeah, it allows us to implement these features really, really fast and roll them out without risking destroying the whole network, basically.
That's a nice feature. Have there been any sporks?
We've had lots of sporks. Pretty much everything that I've done has been a spork since, I don't know, even like maybe a few months into development when we had some issues and I couldn't reverse what I had done without updating the code. And I was thinking, man, it would be nice if I could remotely stop what's happening right now. And then I was like, well, could just cut a section of code and say, if the spork is on, then do this, otherwise don't. It's a pretty easy if-then statement, and then you just activate it with the remote key if you really need to.
Interesting. So you had to push the button.
I've had to push the button a couple times.
So why don't we talk about what is in the future for DarkCoin? What's going on in the community right now? And why don't you tell us a little bit about the possible rebranding?
So lately, the foundation has been looking into a possible rebranding. A while back, a community member suggested the name Dash, which stands for digital cash. And that represents what we're trying to accomplish really well. Fast, instant, fungible money that can be used by everybody. And it doesn't have the negative connotation that the name DarkCoin does. I didn't realize the implications of naming the project DarkCoin at the beginning. I was thinking dark as in private, but it became apparent that the governments and some specific companies have a different understanding of that name. they feel that they couldn't support the project because of that. So it was actually hindering us. But the name Dash has been very well received so far, and we're currently in the end stages of legal work on it. So we're hoping that we can adopt it, but we're not absolutely positive yet.
Let's go right to this question. So are you guys in any way affiliated with Dark Wallet or Dark Market?
No, we're definitely not affiliated with either of those projects.
They're maybe contributing to the sort of connotation you guys are trying to avoid.
I'm not entirely sure. I feel like just from talking to random people about cryptocurrency and what they think about the name DarkCoin, that it just has a negative bias. People just automatically assume that somehow it's for crime, and that was never the intention. The intention was to compete against Bitcoin and to make a better currency and to really try to improve upon the underlying technology.
And has the community been receptive so far to the suggestion?
Yeah, the community has really adopted the name. They're all talking about like different designs right now and all sorts of stuff. It's very exciting.
What else? You mentioned something about the DarkCoin ambassador.
The DarkCoin Ambassador project is a really interesting thing that one of the core team members came up with. His name's Minotaur in the forums. And basically what it is it's a decentralized project where anybody can come join and be an ambassador. And then they get together and they go out to meetups and stuff to try to spread the word of what we're doing. Because we're really trying to be a real currency that will be used all over the world, and something that is capable of mass adoption. So we're trying to get the word out about the features that this offers and things like that. So this program is actually really ambitious, and so far we have about 30 ambassadors all around the world doing this. So it's pretty impressive what they've done so far.
And what about the rest of the infrastructure? Are there any mobile apps that can use DarkCoin?
There's a mobile wallet for Android currently. We're talking about building a decentralized mobile wallet using the Masternode network, which would be really cool. The mobile wallet using Android doesn't actually support InstantX or DarkSend, but the mobile wallet using the Masternode network actually would. So it would be a huge improvement to what we have currently.
Is it a lightweight client like an SPV client, or does it have to trust a server?
It's a full node, the Android wallet is.
Really? How big is your blockchain?
Blockchain's actually pretty small currently.
Oh, okay.
Less than a gig, I think.
Okay. You're still a young cryptocurrency. Well, but is that Android app still going to work when you get into the 10, 15 gigabyte range?
Yeah, so the Masternode network, just like InstantX works, is also capable of doing so many other things. And one of the other things that I had thought of recently was transaction abbreviation. So let's say transaction A pays to transaction B, pays to transaction C, pays to transaction D. You have a chain of 4 transactions. In the middle 3, they don't really have any coins anymore, so they're not very important. So what would happen if the Masternode network could randomly select 10 people deterministically, 10 masternodes, and they could abbreviate that into A pays D, and then they would sign it with their signatures and broadcast it. Now, the full nodes would look at this abbreviated transaction, and then they would look at their existing transactions and verify that they are actually the same, and they would actually replace them. So you could either run an abbreviated wallet, which would sync incredibly fast, or you could run a full node if you wanted, which would have every transaction that ever happened.
Got it. That's a great idea. And that's probably especially going to be helpful with all the large DarkSend transactions.
Yeah, it actually makes bloat not a problem no matter what happens. And it should allow us to scale up a lot faster than Bitcoin can, because it doesn't matter how many transactions are even in blocks at that point. It just matters where the money ended up. And still, if you want to run a client with all of the transactions, you could. So either way you want to do it, you could still do it.
Right. That's very clever. Is there anything else happening in the future for DarkCoin or in the community?
You believe that this architecture has, a lot of potential. And we're actually looking for highly skilled developers to check out the GitHub and spend some time with us and see if they would like to contribute to the project. So that's why we're actually going to start a contest. And this contest is looking for talented core developers to build out Dash and possibly get paid for it. We'll be making a few paid slots available to talented core developers that fit what we're looking for. It's not meant to be a full-time salary, just a token of our appreciation. And if you're interested, please visit darkcoin.io and look for the link Core Developer Contest. This is just work on the core client, though. Other slots could be available at some time later.
Cool. And developers, I'm guessing, are being compensated in DarkCoin, aka Dash?
Yeah.
Cool. Is there anything else you want to mention about the future of DarkCoin or?
We need merchants. If you're a merchant and you're thinking about accepting Bitcoin, why not accept DarkCoin? And if you have an issue with the name, it'll be named Dash pretty soon here.
Right.
And what we're really looking for is to even the playing field. There's a lot of development and a lot of interest in Bitcoin right now. And we want to be the MasterCard to Bitcoin's Visa. We want competition in the space. And that's really what we're looking for.
Where can you buy DarkCoin? Is it on Cryptsy and Shapeshift?
It's on both of those, and it's on Bitfinex. I think there's about 20 exchanges. If you go to darkcoin.io, there's a link to all of the markets where you can actually purchase it, including Chinese markets.
So your mining is up to GPUs. Is this a coin that an amateur or a cryptocurrency newbie can get into and start mining with a minimal investment? Or are you guys already past that point?
We're definitely not past that point, and I don't think we'll be for a very long time. It's going to be incredibly difficult for somebody to get the funding to make an X11 ASIC because it requires them to implement 11 different algorithms, which is enough as incentive to stop them from doing it. So that will definitely take a while. So we should be in the GPU phase maybe even longer than Bitcoin was. And right now we have tons of little small shops and people just mining out of their houses. So it's a really healthy mining ecosystem.
Okay, cool. And what's the website if people want to learn more about DarkCoin or get involved?
The website is darkcoin.io.
Okay, cool. Thanks. Is there anything else you want to add or share with us?
I think that's about it.
Okay. Evan Duffield, thanks for joining us on Let's Talk Bitcoin.
Yeah, thanks for having me. It was fun.
Thanks for listening to this episode of Let's Talk Bitcoin. Content for today's episode was provided by Matthew and Evan. This episode received support from the Tokenly project and also from foldingcoin.net, where you can mine medicine, not hashes. Music for today's episode was provided by Jared Rubens with the LTB theme song and General Fuzz with today's break music called Solace off his album Milestones. This episode was edited by Matthew Zipkin, and show notes come courtesy of R. Frank. See you next time.